Suppose a two-dimensional vector v has magnitude 25 and the x component of v is 7. Find all possible such vectors. Well, if it's a two-dimensional vector, then the vector v would look like 7i plus some unknown, let's just say b is the y component of the unknown. And then if the x component is 7 and y component is b, let's see what this condition means for this. Well, we know that the norm of v is given by square root of the components added up, squared and then added up. So that's the same thing as 7 squared plus 7 squared is 49. 49 plus b squared. And then you say 49 plus b squared is equal to 25. So you square both sides and you get 49 equals to 49 plus b squared equals to 625, because 25 squared is 625. And then subtract, you have b squared equals to, let's see, this will be 576. So you get b as square root of 576. Okay, not so fast. If this was just the Pythagorean theorem and you're trying to find one of the legs, then you would do this. But this is a vector. In a vector, you can have negative values. So you should actually put plus or minus. See, whenever you solve an equation with b squared equal to something, you have to put plus, minus, and square root, right? And if you use a calculator, you can see that this will be 24. And therefore, the two vectors are 7i plus 24j, and the other vectors, there's another vector that will satisfy this condition, which is 7i minus 24j. Graphically, it means this. Let's say 7, here's like 24, and here's negative 24. So you have two vectors of the same size whose x component is 7. And you can draw this, the first vector, 7 plus 24, 7 comma 24, and then the other vector is 7 comma negative 24. As you can see, they both will have the same size, and the size will be 25.